Hello dear students, welcome back to our YouTube channel School for All. So today we are still under the advanced level physics program. We'll talk about circuit problems as last time, and we progress with application of potential and current divider. So I will start here with a small recall. Under potential divider. Under potential divider. So when do we apply the potential divider? We are applying the potential divider, as the name says, divider. It means that when we are having two resistors in series and we connect a PD across them, let's say here V, and we have R1, R2, we all agree with me that the PD here, V1, is different from this one, V2, because they are in series. So when resistors are in series, they share the same voltage depending on their resistances. It means that what? The voltage is shared between R1 and R2 in the ratio R1 is to R2. So if I want to find maybe V1, I will simply take R1 divided by the sum of the ratio, which is R1 plus R2 times who? Times the voltage which is being shared, V. Same thing with V2. V2 will be R2 all over the sum of the ratio R1 plus R2 times the voltage which is being shared, V. So as simple as that, I have the voltage across the resistor R1 and the voltage across the resistor R2. So by doing same with current divider, now for current divider, we apply current divider when resistors are in parallel, because it's parallel connection that divide current into two. Then we connect a PD here. Then this is the current here, which is being divided here into two, I1 and I2. So as I was saying, we apply current divider when we are having two resistors in parallel, R1 and R2. So here, the PD, this is the PD here, V. The current reaching this node is being divided into I1 and I2. It means that I'm sharing I in the ratio, into the ratio 1 over R1 is to 1 over R2, because it is a parallel connection. Anytime we have parallel connection, it's always 1 over R, 1 over R. So if I want to find I1, the current flowing through the first resistor, I will take 1 all over R1 divided by 1 all over R2 plus 1 all over R1 plus 1 over R2 times the current being shared, which is I. By simplification, you will see that the R2 will go up, and then we'll have R1 plus R2. So you can cram it like that directly. So if I'm looking for I1, I will start with R2, because we are having parallel connection. And if I'm looking for I2, I'll have 1 over R2 all over 1 over R1 plus 1 over R2. You see here that on the numerator, I'll instead have R1 all over R1 plus R2 times the current being shared. So you can retain it like that. When you are looking for I1, you start with R2, then sum of the resistor. When you are looking for I2, you start with R1, then sum of the resistor. So that is it. That is a little recall here that I want you people to master before starting an example. Okay. Student, let us now proceed with a small example. So, work example 1. So, example 1, we are having a circuit diagram. It's about circuit diagram. The first question is asking us A. So, for the circuit diagram below, calculate the meter current for each of the following situations. A, X and Y are short. X and Y are short-circuited. X and Y are short-circuited. Now, this is our circuit diagram, and you want to calculate the reading of the meter. We all know that what? If a meter is connected in series, therefore, that should be an ammeter. So, it's measuring what? The current flowing through this branch. So, X and Y are short-circuited. Solution. Short-circuited means what? I will come here, across these 2 points, I will replace it by a line, a wire. That is the meaning of short-circuiting a circuit. By replacing this by a line like this, we see that the current coming from here will reach here, and that current we prefer to pass through this region than to pass here, because here we are having what? We are having a resistor, which is the opposition of flow of what? Of current. So the current reaching here, we prefer to pass through this region than to pass here, because there's a resistor, there's an opposition of the flow of current here. So the equivalent circuit here we can have, after short-circuiting this portion, we will have something like that. Equivalent circuit we are having after short-circuiting this portion. Why? Because when you are short-circuiting this portion, the current is not flowing here. No current is flowing here. It means that this component is useless. The voltage drop across him is 0. Therefore, I can remove it. Therefore, we all agree that the current flowing through this ammeter is I. And we all know from Ohm's law, V equals to I R. This implies my I is simply equals to V on R. And here, V is how many? 6 volts, and R is 3 kilo ohms. So it's the same as 6 volts divided by 3 times 10 to the negative, times 10 to the 3. So making the current to be 2 times 10 to the negative 3 amperes, which is the same as 2 milliamperes. So that is the final answer for A. The current flowing to the ammeter is the current delivered by the battery, 6 volts, and that current is 2 milliamperes. Now let us proceed with the B part. The B part of the question is asking us, give the reading of the ammeter when a 3 kilo ohm resistor is connected between X and Y. It means that I come here and now connect a 3 ohm resistor here, like this, 3 kilo ohm resistor here. So I want now to calculate the reading of the ammeter. Okay, so agree with me that the current reaching here, I, we divide into 2. Let's say I1 and I2. So anytime we are having division of current, we should think about what? Current divider. We should think about current divider. So this I1, which is the current which is flowing through this branch, so therefore it is the current measured by the ammeter, is flowing through which resistor? The 3 kilo ohm resistor. It means that by applying current divider, my I1 will be simply equals to, now remember when you're talking about current divider, rather than starting with its resistor, or let's say with the resistance 3 kilo ohm, I will first of all start with the 6 kilo ohms. Remember, when I have I1, I take R2 all over R2 plus R1 times I. It's the same thing I will apply here. This I1, I will take, rather than taking 3 kilo ohms, I will start with 6 kilo ohms all over 6 kilo ohms plus 3 kilo ohms times the current flowing in the circuit, which is I. But we should find the value of I. Now, how can we find the value of R? It's simple. From V equals to IR implies I is simply equals to V times R total, where R total is the equivalent. It's the equivalent resistance of the circuit. So R total, let us calculate R total. R total will be what? These two are in parallel and then in series with this one. So it will be 3 plus 6 times 3, all over 6 plus 3, parallel, product all over sum. So it will be 3 plus 18 all over 9, which is 3 plus 5. 3 plus 2, pardon, making 5 kilo ohms. So that is R total. So the value of R total now, I can calculate now the value of I. So my I is simply equals to V, which is 6 volts, divided by 5 times 10 to the 3 ohms. So making I to be equal to, so by numerical application, we will have 6 divided by 5 exponent 3, which is 1.2 times 10 to the negative 3 is same as 1.2 milliamperes. So there is the value of I. Now with the value of I, we can rapidly find out the current flowing through the ammeter, and that current is I1. It will be simply equals to what? 6 kilo ohms all over 6 plus 3, 9 kilo ohms times the current, which is 1.2 milliamperes. Now kilo ohm cancel with kilo ohm. When we take now 6 divided by 9, we have 0 point something, 2 all over 3, so it will be 2 all over 3 times 1.2, making a total of 0.8 milliamperes. Making a total of 0.8 milliamperes. So this is the value of the current flowing through the ammeter by applying current divider.